Good morning, everyone. Today we will be talking about exponential growth and decay. So our objective is to identify and interpret exponential growth and decay. On the agenda, we've got the video. Thank you for watching. We're going to go over some definitions and examples, and then your classwork will be a Google form. First, we're going to start with that do now. So what I want you to do is take a second on your own, pause the video, and try to simplify the following exponential expressions. Alright, so hopefully you have completed this, and this is something we talked about when we were doing properties of exponents, right? So for number 1, we just have 5 to the third. You could plug this into your calculator, or you could rewrite this as 5 times 5 times 5, because since we're at the third power, we need 1, 2, 3 5s. 5 times 5 is 25. 25 times 5 is 125. So that would be our final answer here. Number 2 is a little trickier. We need to remember our property of exponents, quotient to a power from properties of exponents. So what we do here is that 3 applies to both the numerator and the denominator. So we get x to the third over y to the third. All right, that's from our properties of exponents unit that we did back in February. Third, number 3, same thing. We're still using quotient to a power, but now we have numbers instead of variables. So we have 1 to the third over 2 to the third, and now we can simplify. 1 to the third, 1 times 1 times 1 over 2 to the third, 2 times 2 times 2. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. So our final answer would be 1/8. Now I'll show you how this is going to come into play when we talk about exponential growth and decay. Okay, so first let's really quick review exponential growth. Oops, let me get the paper in there. Okay, so before we were talking about a geometric sequence when we're multiplying everything by a constant. And when we were talking about exponential growth, we were multiplying each of our values by a whole number, or a number that was bigger than 1. So if we start, say we start at 0, and say my first value is 3. If I want to choose a constant to multiply by, let me say we'll multiply by 2 each time. So if I go to 1, 3 times 2 is 6. Then if I go to 2, 6 times 2 would be 12. And I could keep going, right? I can also go backwards to see, okay, -1. What times 2 would give me 3? Or I could do 3 divided by 2, which would be 3/2, or you could write 1.5. So we have times 2 again. All right, now let's graph this really quick, okay? I'm going to change the scale of my graph so that I'm able to fit everything on here. So I'm going to have 1, 2, -1. But let's go 3, 6, 9, 12. Can we do that? 3, 6, 9, 12. So I'm still linear, but I'm increasing by 3 every time on my graph. Okay, so if I'm going to graph this function, at -1, I'm at 3/2, or 1.5, which would be between 0 and 3. So -1, 1.5, 0, 3, 1, 6, and 2, 12. And we see that classic curve, right, of our exponential growth. You can tell as we move from left to right, We are growing, 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 up, up, up. We've got that end behavior going to positive infinity as x goes to infinity, right? And what we can do is, using our formula from yesterday, or the last lesson, we know that our exponential formulas are always in the form a times b to the x, where a is the y-intercept, right? And b is our exponent base, or we're going to call that the ratio today. Okay, so if we want to write an equation using this table, I've got my y-intercept here, so I can say y equals, my y value is 3, that's my y-intercept, and then times my b is going to be whatever this ratio is, so times 2 every time to the x. Okay, so I've been able to write an exponential growth equation. So let's talk about exponential decay now. I'm going to move over, I'm going to do the same table, and let's actually start this at the exact same spot. So if we start at 0, 3 again, but now instead of growing every time I move up, so as I increase in x, I was growing. Now as I increase of x, I want to decay or deteriorate, right? I want to get smaller. So let's multiply by 1/2 each time. That's the same thing as dividing by 2. So I'm going to have 3/2. Then if I multiply by 1/2 one more time, I'll get 3/4. Okay, so how I got that, right, is I would have 3/2 times 1/2. 3 times 1 is 3. 2 times 2 is 4. That's how I'm getting 3/4 here. All right, and again, if I go backwards, for -1, something times 1/2 gives me 3. So I really can multiply 3 by 2 to go backwards and get 6 here. All right, and if I graph this again, I'm going to use the same scale from our original graph. -1, 1, 2, and we'll go 3, 6, 9, 12. Now at -1, we're up to 6, 0, 3, 1, 3/2, and 2, 3/4. 3/4 as a decimal would be less than 1, right? So we have 1.5 here, and then something that's less than 1. So we are getting closer and closer to 0. And with exponential decay like this, ooh, excuse me. With exponential decay, we're going to get closer and closer to 0, but never quite touch 0, right? So that end behavior would be, as x approaches infinity, f of x is approaching 0. Okay, so this is an example of exponential decay. And if I'm going to write a formula for that, or my function notation, again, we're going to take my y-intercept, my a value is 3, times my ratio, which this time is 1/2. I'm going to put this in parentheses, to the x. All right, so let's formalize that definition. When I'm given my basic exponential formula, y equals a times b to the x, exponential growth will be if we have a b value greater than 1. And that's really the absolute value of b, greater than 1. So for example, that b value greater than 1 was in our exponential growth up here. We have a b value of 2. b equals 2. We had a being 3. And here we had b as 1/2, a is 3. Exponential decay will be any time that the absolute value of my b value is less than 1. Okay? So that means any decimal or fraction less than 1. Okay, so we're thinking like 0.8 or 5/6. That would be decay. Growth is anything greater than 1. So even if we have a decimal, that's greater than 1, so that's fine. Or even if we have a fraction, what if I had 8/6? My numerator is larger than my denominator, so that's still greater than 1. All right. So let's go ahead and do some examples real quick. And this is what your classwork will look like on the Google form, but you'll have multiple choice. Okay? So, number 1, are the following functions examples of exponential growth or decay? All right. So a is f of x equals 4 times 3.2 to the x. Now remember, when we're thinking exponential growth and decay, we're thinking about our exponential function, and we want to look at the b value. We're always going to look at the b value to determine. So here, my b is 3.2. And we think, okay, is 3.2 greater than 1 or less than 1? 3.2 is greater than 1, so that means we have growth. All right, b, f of x equals 0.5 times 6 to the x. I'm looking at my b value. My b value is 6. 6 is greater than 1, so we have growth. C, f of x equals 3 times 5/7 to the x. My b value is 5/7. 5/7 is less than 1. So we have decay. D, f of x equals 0.2 times 0.8 to the x. I'm looking at my b value, which is 0.8, which is less than 1. So that will also be decay. All right, pause that and go back if you need to. If you're ready, we're moving on to part 2. What is the shape of the graph for each of the following functions? Okay, so what we're thinking about here is we're thinking back to our examples here. Exponential growth will always have this upward curve. Exponential decay will always have this downward curve. So here, we're going to think, okay, again, looking at my b value for h of t equals 0.7 times 5.6 to the t, my b value is 5.6. Since b equals 5.6, which is greater than 1, we have growth, and growth will always be this shape. All right, part B, g of t equals 1.7 times 0.8 to the t. 0.8 is my v value. 0.8 is less than 1. So we'll have decay. More like that. Okay, C, h of x, 2.05 times 3 to the x. 3 is greater than 1, so I have growth again. D, f of x equals 3 times 7/4 to the x. 7/4 is greater than 1 or less than 1. 7/4. 7 is larger than 4, so this is greater than 1, and we have growth again. All right, so for your classwork, you'll be doing this in Google Forms. If you do not get more than a 50% the first time, you can retake it. Always retake it in order to get full credit, okay? You have the ability to retake those forms as many times as you want. And please attend office hours if you have any questions, or feel free to text me or email me. All right, good luck. I will talk to you all later.